A very good morning, everyone. Thank you for joining us today while we are discussing cloud computing and how to ride the wave of cloud. Let's get into it. Cloud computing, from a disruption standpoint, an opportunity, whether it's an opportunity, getting to know it, and we can benefit from it. Yes, obviously, cloud is definitely a disruption. The point that it enables several new customers, several small and medium enterprises, and even each of us as people and able to do business from homes. Cloud is a big enabler. Cloud also provides a lot of benefits and uh, lets the non-traditional bottom of the pyramid mass markets benefit by providing low cost access to everybody to resources which was never available. And cloud also is an entry point to the new technology ecosystem, which is continuous, evolutionary, and data driven in nature. So there is no doubt we understand like software is eating the world. Welcome to a software driven world. It's very important that we understand it better. The questions of small and medium enterprises obviously revolve around how much should I pay upfront? How can I scale? Obviously, cloud as a solution provides you, like any other utility infrastructure, capability to pay as you go, which is very important part of it. And again, you can scale infinitely and shrink as well as per the needs of the business, as per the needs of the end users. So that really addresses and gives a kind of new capability to the small and medium enterprises, while the corporations at the same time are left with thinking, how can I speed up my time to market? How can we enter new markets? Obviously, cloud has an answer for that as well. It is providing an infrastructure and capability which allows you to continuously provision, create a new structure for a new market, and able to deploy it on a continuous manner. And with the kind of resource capabilities it provides, you can always make changes, leaping sideways, change directions, and make accordingly to the end users that you see and the pivot there according to their behaviors. This is really more power to the makers. But how can I really benefit? How can I get to know better? Cloud computing is, by its definition, a model which enables on-demand, ubiquitous, convenient demand network access. It provides network access to a shared pool of computing resources, which includes network servers and storage. So you should see that it includes a combination of computing, storage, and network, not just computing alone. And again, the killer capability is about the ability to rapidly create or provision and then able to also go back to the previous state, release this with minimal management effort. So you see the kind of evolutionary nature of the cloud is inbuilt in it. It allows you to kind of scale like a organism or animal when a security it attacks, it is attacked, kind of changes shape. That kind of you can change your form and function and the shape that you are owning with the capability that the cloud has. And this is where it is much more than just a technology consideration. Instead, it is more of a model, and that is where it's important to handle it like a model. And then when we let us get delved a little bit deeper into it, it has five characteristics for deployment models, three service models, to name a little bit. Go further into this. When we are talking about five characteristics, just broad network access, and with the coming of 5G, we will also see the even the last miles getting connected, on-demand self-service, which is kind of a unique capability which allows you on your fingertips locked up power, ability to resource pool and virtualize, which is the underneath capability of the cloud, able to be rapid elasticity, like able to scale up and down, and then as for pay per go, measure the service provided both for yourself and for your customers. These five characteristics are very key and kind of provides every business a unique capability which was never available earlier. Then you have the capability of four deployment models where we are talking about public cloud, everything on the internet, private clouds, which is secured and specific connected for the organizations or community where business communities come out, and then hybrids that are kind of uh, combining all these methods. Typically, you will also see the cloud providers providing infrastructure as a service, platform as a service, or software as a service approaches, and cloud providers has a particularly infrastructure as a service which provides VMs and storage and network kind of capabilities from which you can start like outsourcing your IT organizations. Azure or AWS are good examples. Platform as a service is Windows as a platform itself available, so that you need not start from um, basic infrastructure. Instead, you already have the platform and you can start using the platform or Elastic Beanstalk. Software as a service obviously is a playground for all the software companies where they want to be software as a service companies. Soho, Salesforce are CRM examples to this. So you will see across the board several other augmented capabilities, including knowledge as a service, innovation as a service, kind of coming into this picture based on these three service models. While cloud is a great benefit, at the same time, it's important we understand its pitfalls or kind of challenges that we have to be looking forward. High availability is very important, and there again we have to make sure our applications are available. We also have to ensure that the services that the cloud provider provides are also of the same nature. Confidentiality of the data, several data is getting shared, and how do we handle the confidentiality, the auditability angle of things, how can we ensure that these systems are auditable, or security audits can be done, or safety audits can be done, or backup, data transfer aspects, how we send the data across, what kind of data, and how do we ensure security considerations which allows us to ward off the security risks as well. It's a lot of power. Obviously, with a lot of power comes a lot of responsibility. And then, so now we are left with being an application or embedded developer. And how can I make use of it? How does it help? How can I learn? So many questions. From an application developer perspective, you will see it from as enabling a kind of infinite scale with distributed design considerations like RESTful or microservices and combination of small NoSQL or RDBMS databases and Docker containers to handle dependency. You can scale a lot. And with the support of Kubernetes and other kind of environments, if failure happens, you have a way to handle those failures and spawn other containers, and thereby service so the end user doesn't see failure. While on the other side, on the embedded world, it enables you to be connected, where embedded systems obviously has limited computing capabilities. You can really benefit from integrating it with the cloud and able to send the relevant data to the cloud for intensive processing. This kind of provides you a product service system which enables you to certain functionality could be fully on the cloud as well, and then some of this functionality can be in the interaction between cloud as well as device. We are obviously, like Ian Woods famously pointed out, we are moving towards intelligent connected systems, and this is a path for intelligent connected systems. So while we are getting there, How do we really learn? What kind of steps should we take? That's an important question for us to understand. And there are so many things around. What should I learn? As a beginner, obviously, you might, an embedded developer, an application developer, I believe you'd be aware of the HTTP as a protocol, the internet protocols, and then obviously cost considerations of cloud are different because subscription based, it is a movement from capital to um, yeah, operation expenditure, which is continuous in nature. Privacy and security considerations slightly differ. So just to understand the differences and learn from there. And then the next major step is to look at RESTful API. RESTful API kind of the considerations about stateless nature of HTTP, hypermedia, URI, HTTP, applying HTTP verbs are very important part of the story because this architecture style is very evident and whatever you apply mostly using gRPC or Google Protocol Buffer or considerations of that sort obviously have a relationship to these. And then it's also important to identify relevant use cases applied, then move to availability and reliability. Availability is highly significant from an application developer standpoint, while reliability will be more important from embedded developer standpoint. But both are becoming more and more significant with the software, particularly on the cloud. And continuous deployment becomes a necessity because if you have to provide the kind of availability, kind of reliability, obviously you should have a system which allows you to continuously deploy this and as part of it do the continuous integration tests and integration as well as you go. So it's very important and kind of stay closer to the customers because the customer trust is also important and how well you test enables trust for the customer. Connected systems, we are obviously moving towards connected systems where we are going no more going to see internet just as a pipeline but being able to right kind of send the right kind of data and being able to do the right kind of interactions across the system. And then obviously the major steps are in the data science and AI aspects. Obviously, data science more probably puts us to insights, delivering insights from the data, while AI looks at more from the autonomy aspect, able to um, bring out insights and based on that make decisions and take actions. So obviously, this is on the path of intelligent connected systems and obviously even internet of things also indulge in this area of work. Thank you for your kind attention. This is the book we have referred to particularly, and Roy Fielding's book is very important from the perspective of rest, and cloud computing engineering and management is a course which I have also done as part of the from edX. Thank you for your kind attention and have a great day.